The purpose of this video module is to familiarize you with the landing gear system on the Boeing 767. You will be shown the function and operation of both the nose gear and main gear, as well as the access and location of their major components. We will begin by looking at the landing gear control and indication components common to both the nose gear and main gear. We will then look at the operation and major components of the nose gear and main gear. The control and indication components are located on the first officer's instrument panel. These include the landing gear lever lock override, alternate gear extension switch, and the position indicator lights. The green landing gear lights are illuminated when the gear is in the down and locked position. The amber warning lights are illuminated when the gear is in transit or if an abnormal condition exists. In the event of an abnormal condition, a message will appear on the Engine Indication and Crew Alerting System, or ICAS. The nose and main landing gear systems are operated by pressure from the center hydraulic system. We will now look at the major components and operation of the nose gear system. This system includes two wheels on a single axle truck, a typical shock strut, and a retract actuator attached to the support beam. The nose gear structure is held in position while extended or retracted by an over-center type lock link. Additional system components include a tow lever that allows for towing of the airplane without depressurizing the hydraulics, two steering actuators, and a tow fitting. There are 4 nose gear doors, 2 aft and 2 forward. These doors are operated by a mechanical linkage. The forward doors are normally closed when the gear is extended or retracted. When the landing gear lever is placed in the up position, hydraulic pressure to the retract actuator is momentarily inhibited while the lock actuator removes the over-center condition of the lock link. The nose gear doors are mechanically opened as the gear begins to retract and closed by mechanical linkages when the gear is fully retracted. Extension is essentially the reverse of retraction. When the landing gear lever is placed in the down position, hydraulic pressure to the retract actuator is momentarily inhibited, while the lock actuator removes the over-center condition of the lock link. As the nose gear extends, the nose gear doors open. When the nose gear is fully extended, the forward doors will close, while the aft doors will remain open. When the ground release handle is pulled, the forward doors will drop open to allow access. This is a mechanical operation. The nose gear alternate extend mechanism is located in the aft end of the nose wheel well compartment. When the roller contacts the lock link, the over-center locking of the lock link is broken and the gear will free fall to the down and locked position. Extension of the nose gear strut after takeoff, along with main gear truck tilt, provides air-ground sensing through proximity sensors. There are 2 air-ground sensors on the nose gear assembly. We will now look at the operation and major components of the main landing gear system. The main gear system includes 4 wheels and brakes on a dual-axle truck, a retract actuator mounted in the wing outboard of the trunnion, and a typical shock strut. The structure is supported in the extended position by the drag strut and side strut. These are locked in the extended position by a jury strut and a lock link. which are locked over center by hydraulic actuators, and bungees. The main gear door, along with the up-lock hook, maintains the gear in an up and locked position. Other doors associated with the main landing gear include the pop-up door, which is on top of the wing and cannot be seen here, the trunnion door, shock strut door, and drag strut door. These doors are mechanically operated by gear movement. After takeoff, the landing gear trucks are hydraulically tilted forward 17 degrees to allow the gear structure to fit into the wheel well. Tilting is automatically accomplished by a hydraulic actuator mounted between the aft side of the shock strut and truck beam. The action of the trucks tilting forward provides air-ground sensing through proximity sensors. There are two independent air-ground sensing systems that provide switching and control functions for various aircraft systems. An electronic signal energizes a solenoid in the landing gear lever module. This allows the gear lever to be placed in the up position. Without tilt indication from both trucks, the gear cannot be retracted except by manually overriding the system. When the gear lever is placed in the up position, hydraulic pressure is ported to unlatch and open the main door. Pressure to the gear retract actuator is inhibited by a door sequence valve located in the left wheel well until the door is open. Initially, the downlock actuators begin overriding the bungees. The jury strut and lock link then unlock and fold with the drag strut and side strut. The main gear door will start closing just before the gear has completely retracted. Retraction is complete when the door latches with the uplock hook. When the gear is up and the door is closed and locked, the gear lever is placed in the off position. This depressurizes the entire landing gear hydraulic system. When the landing gear lever is placed in the down position, hydraulic pressure is ported to unlatch and open the main door, as well as pressurize the downlock actuators. The retract actuator and transfer cylinder prevent extension of the gear until the door is sufficiently open. As the gear approaches the down position, the gear-operated sequence valve cycles. This ports hydraulic pressure to close the door. Upon full extension of the gear, the down locks, in combination with the bungees, lock both the side strut and drag strut. Normal time for retraction and extension of the landing gear is approximately 12 seconds. A door ground release lever is located aft of each main gear wheel well. These levers manually release the main gear door uplock hooks. Warning: the main gear door ground release levers should be locked and pinned in the open position before personnel or equipment are allowed in the wheel well area. In addition, door locks should be installed in the main gear doors. The main gear doors can be closed by unlatching and stowing the door ground release lever. The ground door release and alternate extend systems use common components. The main gear alternate extension unlocks the main doors, which in turn allows the gear to free fall to the down and locked position. An electric actuator located in the flight compartment provides a command signal to rotate the cable release quadrants in the top of the wheel well. These quadrants then operate the rods and cranks that rotate the door uplock hook, as well as the door safety valve located just above the uplock hook. This video module has introduced the landing gear systems on the Boeing 767. We have seen the function and operation of both the nose gear and main gear assemblies, as well as identified their major components.